So hi, thank you for joining my talk. My name is Jigar. I work at TouchLab, and today I'm going to talk about integrating Kotlin JS in a Kotlin Multiplatform library. So we at TouchLab, we are the Kotlin Multiplatform Mobile experts, where we build client apps and SDKs and even do training in Kotlin Multiplatform. So let's start with a bit of a history. So we started using the Kotlin JS in production apps in like late 2021 at TouchLab. So when we started, like I was a newbie in terms of JS world because I'm an Android dev, so I didn't know much. So there was not many resources available at the time to refer the Kotlin JS. The only thing which was available was more of a React native side of the Kotlin JS. But luckily, the Kotlin docs, which are fantastic to give all the information. And also in Kotlin Slack, we have a JavaScript channel. So a lot of people who help a lot in terms of answering questions. So that really made me started very well. So we started with like Kotlin 1.5.32. It was quite a bumpy ride because we did not have much of the things available to use in JS at the time. Things got better with 1.6.20, and then of course we now have 1.7.10, which definitely improved the things a bit. But still there is a long way to go. So to get back to the basics, what is Kotlin JS? So Kotlin JS is basically Kotlin for JavaScript. So what you do is basically JavaScript is a supported platform in the Kotlin ecosystem. So you write Kotlin code and it gets transpiled into JavaScript. So think of it just like how Typescript transpiles into JavaScript. Similarly, that's how Kotlin works. The best part of Kotlin JS is the solid Gradle plugin. So what it does a lot of heavy lifting behind the scenes. So it includes the NPM handling, it includes the yarn, it also includes the Webpack, all the JavaScript ecosystem included in the Gradle plugin. So for a newbie like me who was an Android developer, it really made a change because then I didn't have to worry about installing all this ecosystem, understanding what is yarn, what is Webpack. So it's definitely newbie approved. And for the support-wise, Kotlin JS supports a variety of projects. So you can build like a front-end UI application, so you can HTML, CSS, or even like a React app using Kotlin. You can create like a Node module where if you're building a Node server, you can use Kotlin JS to build a Node server. You can also write JavaScript and TypeScript libraries using Kotlin JS. And last bit, which is what we are here for, is the Kotlin Multiplatform support for the Kotlin JS. So how do you set up? So setting up Kotlin JS in a multi-platform project is pretty easy. So if you have seen a Kotlin Multiplatform project before, you will have like an Android or an iOS target. Similarly, you can create a JavaScript target, and that's about it. Now, if you're wondering what those browser and binary executables are, we'll come to that later. So if you have a project, if you add these 4 lines, and if you do the build sync, there is a high possibility you will end up with this error. And what this error means is there is a clean task which comes with like an Android project, and then Kotlin JS target also adds a the clean task. So most people basically end up asking a question on Stack Overflow or Kotlin Slack, okay, what is this error? So basically, you go to your root build or Gradle project and remove that clean method, and that should be good to go. So if you find that if you're trying out the JS, then make sure you remove that. There is a second optional step you can do. So you might want to add the JS main and JS test source set. If you're already using the hierarchical project setup in Kotlin, then you don't actually need this. So I think Kotlin made that by default, I think starting 1.6.10. So if you don't need it, but if you're using the older Kotlin version, or if you're planning to add some dependencies later, you might just add the source set support. If you look at your the source folders in a Kotlin Multiplatform Mobile project, you will potentially have an Android main, common main, and iOS main. So once you add the JavaScript support, you also want to add a JS main and a JS test folders. So at this point, everything should be okay, and you should be able to start a greenfield project, for example. But what if you already have an existing project? If you already have the Kotlin Multiplatform Mobile project, there is a high chance that your build will fail at this point. And why, and how do you solve it? So there are 2 steps you can take. So first step is basically you refactor your code in your common main so it becomes compatible with JS. For example, if you have any expect actual declarations, then you want to also add the JS side of those declarations so your JS code compiles. If you have a large complex project, you can have so many of those things refactor. So it can be overwhelming with a lot of upfront work. So we would like to suggest usually a second option to solve this problem is basically introducing a new common source set for mobile platforms. So what this means? So let's think of it as adding a mobile main source set, and then what it does is your Android and iOS source set will depend on a mobile source set. So why is that? So we have seen that Android and iOS has very similar capabilities. So we'll have similar kind of serialization, similar threading concepts, and even concurrency and things like that. Versus if you think about JS and web platforms, it can be handled very differently. Like JSON can be differently handled, and there is no concurrency, so it's just single threaded. So it can also be differently handled. So what mobile main gives you is allows you to have that separation over Android and iOS versus web. So then in future, you don't want to anticipate writing or refactoring your code again and again. So there are basically 3 steps to do this. You add a mobile main source set. You move your entire common main to mobile main. So at this point, it's just cut and paste all the code. So once you do that, you basically have a mobile main which has all your common code, and then JS main will be empty. And you can now compile your project with Android, iOS, and JavaScript. Of course, JavaScript will be empty at this point. But then you can take baby steps to slowly add JS support, so you're not overwhelmed with a lot of upfront work. So if you add like a mobile main source set, it might look like this, where you're adding a mobile main and making Android and iOS depend on it. Similarly for mobile test. And your source folder structure will also look like that, with new JS main and new mobile main. So you're good to go at this point, and start writing some JS code. Now you're wondering that JS has so many things. You can have a Node module, you can have a JS library. So how do you know what you want out of your JS library? Or if you already have a website and you want to use a particular file system of your JS library, how you do it? So let's look at the JS build outer for that. So earlier we saw this JS target code. So let's dive into it about what those options mean. So that IR, it is basically a compiler option. So Kotlin JS has a new compiler called IR. It is called intermediate representation. It is what Kotlin now suggests to use in all the JS project. It includes like dead code elimination. It also includes like experimental TypeScript support, which was not there in the legacy compiler. So there is one more option. If you see the documentation, that there is a legacy option for here, but it's at this point not recommended. But you can definitely use it if you have an old existing library. The next one is that browser declaration. So what does that mean? So that just tells Kotlin compiler that I want to use browser as a JS target. So if you're writing potentially a web app or a web module, then you want to use browser as your target. Kotlin also has a standard JS library, just like it has the JVM and native standard libraries. And it has a lot of the browser-related HTML APIs, and also like window fetch APIs and all that. So you just need that default standard library, and you're good to go. The another option instead of browser is the Node.js option. So it's pretty similar in terms of you're telling compiler that I want to create a Node.js as a JS target. So you're likely building, if a Node application or a server, Node server, you will basically be using the Node.js. Another helpful thing is Kotlin JS has a experimental Node.js library where it basically has all the Node APIs available. And then you can use that to write Kotlin code using the Node.js APIs. The third option you can use is the binaries executable. So this basically determines the output of your JS. So it tells the Kotlin to output JS as a single executable file. So it uses the Webpack bundle tool. Webpack is like a bundler tool for JavaScript. We probably won't know because we are the Android devs. But what it does is it gets all your dependencies and compiles them into just one file. So rather than you have multiple files. It also includes like something called dead code elimination. So if you're not using a particular code, then it will remove that, just like how we think of it as ProGuard, and then it will basically reduce your binary size. The last option we have is the binary is called library, and you will use that if you want to create a JS library. For example, if you want to create an NPM module, if you already have a website and it uses NPM module, then you want to use this library function so that you generate a library. It also includes experimental TypeScript support. So once you create an output, you will have the .d.ts file. So if you're looking for TypeScript files, then you basically be wanting to use the library feature. There is also an awesome open source NPM publish plugin by Martinas, and what it does, it allows you to do the NPM publish very easily. Just like how we have the Maven publish plugin, it aims at the similar concept that you want to do the NPM quickly. Now, if you look at the Gradle task for each of them, there's a Gradle task called JS browser distribution. If you are building a production output, you want to use that Gradle task. There is also a development web task available. What it does is it does not do the dead code animation, so it's definitely faster. So if you're building a lot, then you probably want to use the development task. So if you look at the output, you will have a distributions folder in your build folder of your module, and you will have a shared.js and shared.js.map file. The map file is basically useful for debugging. It basically contains all the references of your code, so the debugging is pretty easy. It doesn't work all the time very well, but it's definitely a good starting point. If you look at the share.js, it has that name from the module. So that's something you don't want, because you don't want your library to be called just your shared. So you can again go back to the browser task, and then the browser has a Webpack task in the DSL, and then there you can basically change your file name or your library name. If you see, there is also a DCE task. So what it does is you can pick and choose what you want to eliminate in your dead code elimination. So just like in ProGuard, we have the keep version where we want to keep certain things from not being obfuscated. It does a similar thing. So this is how we want to build the binary executable using the Webpack. Now, if you want to build the library distribution, there's a slightly different Gradle command, but it's basically browser production library distribution. It's self-explanatory in the wording. There is no develop specific version of this, because at this point they both do the same job. You look at the output for the production library. Now you will see that you have a Kotlin standard library JS, which I was just explaining before, and then you will have your own shared library, and then you have the TypeScript file, the JS file, and the map file. Now the naming here is slightly different than what we saw before. And you also, if you look at the packet.json, you will see a violation warning, because NPM does not allow capitalized words. So this is something you will not get warned, but it will by default uses your project name and the module name to create that your library name. So there is also a simple solution. You use that JS target block and provide it a module name, and then it will use that module name when it's creating the library output. So at this point, we understand that how we want to get the output, and then how we set up the Kotlin JS. Now the third point is how we actually write Kotlin code so that it shows up on the JS side. So since we have the Kotlin main and the Kotlin the JS main, if we write a simple class called greeting, and then there's a platform class, this is like a sample from a default Android Studio project, and you will have the actual platform implementation on the JS side. And if you run the outputs, your JavaScript will be empty at this point, because Kotlin by default does not export JavaScript. To solve this, you basically need a JS export annotation. So what JS export annotation does, it tells Kotlin that I want this Kotlin code to be exposed on JavaScript side. So Kotlin will then generate a greeting class for the JavaScript. Note that this is an experimental annotation. So you might want to use the language settings to add an opt-in so that you don't see warnings everywhere in your code. So for this, since we added the JavaScript export, we see the code generation for JavaScript, and that's a greeting class with the greeting method for the TypeScript. And then also, if you look at the JS file, it similarly, it has a platform class. You see the prototype.a, which is the obfuscated name for the dot name, and then the metadata files for the JavaScript. So at this point, we have this JavaScript and TypeScript files. And if you want to use them in your JavaScript or TypeScript application, you will basically use them like that. So you're importing the SDK, whatever name you have given to your object for your library, and you create a new class, and then you do a console output, for example. The interesting to note here is the package naming convention. So what Kotlin does is it exports all the classes with the fully qualified package names. So since we had the package name and then we imported the SDK, now we have to write that whole new SDK.packagename.class. So this is something just to look out for, because I've seen people looking, say, I can't find my class, but the reason is because you have to just use the fully qualified Kotlin package. Another thing to keep in mind is all your exportable references needs to be completely exported. So here we have the person class, which is exported, but the address class is not exported. So then you are seeing the export declaration uses non-exportable parameter, which is the warning. So Kotlin does not understand that how do I export this, because it's not exportable. So you just want to make sure your address is also JS exported. So if you look at the state of the things, the challenges are not everything is exportable at this point, or if something is still buggy. For example, biggest problem we face is there is no support for exporting collections API. So you cannot write a map or list in your Kotlin code and export it and use in JavaScript or TypeScript, because it's not possible. So you might have to refactor your common code to use arrays. Using array can also have other consequences, like if you're using array in your data classes, then you might have to override the hash code and the equals implementation. So it gets tricky about how you write your common code with that. Even suspended functions are not exportable at this point, so you might have to use the Kotlin promise. If you do something wrong, you will basically see two types of errors or warnings. So one is the kind of error where Kotlin will say that I just cannot export this, it's not possible, just like how it happens on the suspended function. So it will tell you it can be exported and it will be an error. Another kinds are like when I'm using the list, it shows me error that it cannot export that type, but it's still a warning. So if you do this, then you will basically see something wonky on the JavaScript side. Or on the TypeScript side, you will get like an any or something, so that you basically, the TypeScript does not understand what is the actual type. There are positives to this. Kotlin 6.2.20, it includes the enum and interfaces support. So like when we started, we had to refactor a lot of our code because we just could not use enum and interfaces. So things got improved and we refactored the code again, and now we have some more support. Experimental TypeScript support is also improved. There are also libraries like Kotlin wrapper library, which also provided by JetBrains. So think of it as the Kotlin extensions library we had for Android. So what they do is they provide a lot of supported APIs for the JavaScript, so that since you don't have it from the official platform APIs, you can use the wrapper library to get some more official functions. There's also people who are using Kotlin symbol processing to add like a custom export library. They provide missing functionality. So if Kotlin team is not doing something and they want to use, they are basically using KSP to find solutions. The another interesting bit about the JS export is if you have something like greeting and the greeting method with a version, this is completely fine with Kotlin. It's the overriding methods, but it's something is not supported on JavaScript side. So if you're writing something where you are overriding methods, then it will tell you that the declarations are clashing. So for that, you can use the JS name annotation. And then give it a different name. So then JavaScript will basically have two different methods when it's generated code. This is just like how there is a JVM name annotation where you could write a different you could have a different name on the JavaScript side for your Kotlin APIs. So now, if you run the code and create the binary, you see the greeting and the greeting with version methods on Typescript. There are also a couple of more things I wanted to show you is the dynamic keyword and the JS object, the JS method. So what it does is you can write any JavaScript code in Kotlin, and it will basically run as a JavaScript. So this is what the JavaScript method does, and then you can write any JavaScript code. Similarly, since Kotlin does not have all the JavaScript support, what it does is it provides a dynamic type. So whenever you use dynamic type, Kotlin basically turns off any type checking. So if you have an API which Kotlin does not understand, or a type which is Kotlin does not understand, you can use dynamic and then internally Kotlin assumes that you know what you're doing, and then it's allowing to use dynamic type. But then if you're not sure what you're doing, then you might basically break your code at runtime. So we saw how you write Kotlin code to write JavaScript. Now what about third-party dependencies? So if your library already is available with multi-platform JS support, you're good to go. For example, Kotlin coroutines, it has a JS support. So if you're using Kotlin coroutines, you're good to go, and then you don't have any additional work to do. But what if you want to use like a JS-specific library, like an NPM module? Then Kotlin also provides a way to add an NPM module using the implementation declaration. So here we wanted to use the Launch Darkly SDK in one of our projects. So we just added the NPM module for the Launch Darkly and with a specific version, and then we could use it. The thing is, Kotlin still needs to understand how it uses the NPM module using Kotlin. So it basically expects you to write external declarations for all your NPM modules. So you basically write a method which follows this Launch Darkly API for the JS, so with the external keywords. So here we are letting it know that there's a JS module, which is a Launch Darkly NPM module name, and then there is an external function called initialize, and you write this in a Kotlin file, and then Kotlin understands that Kotlin calls this library and this method at the runtime and assumes that the JS library will have it at the runtime. Now, as I said, I was a newbie when I started in terms of JavaScript. So I didn't know what all this means, and I didn't know how to even read the TypeScript file and JavaScript file. So I needed some help. There is an help available. It's called a tool called Dukat. So what Dukat does, it basically generates external keywords, external declarations for any library you provide it. So in the same NPM declaration, you write generate externals true. And what Dukat does is it goes to find TypeScript definition for that library NPM package, and then it generates them in the external folder of your build folder. So now you see that it created the Launch Darkly KT files with common and some other packages. Now, you can definitely use this, but the thing is, Dukat is experimental, so you might have some things which are working, which are not working. So the way I have found a solution is that I copy what I need from what the Dukat generates, and then I paste it in my module. The reason is, if I keep using the same generated files, then it will get override whenever there's a new version or something. So I copy what I need, I paste it, and then I fix if the declarations are broken. And then I remove the generated external keyword, so then it does not generate it over and over again. So that's like the solution I found, which works out well for most of the libraries. Now, if you're new to JavaScript world, how do you know there is a TypeScript support for an NPM module? So if you go to any NPM module, and if it's open source, you go to typings.d.ts. For example, this is a Launch Darkly NPM module, and you see that these are the methods and interfaces available. So you know that the TypeScript support is available. And then if you see Kotlin generated very similar code for it, and it is similar external interfaces, external objects, and external functions. And there is also the at file level JS module annotation. So it's pretty similar to what the TypeScript looks like. Now, if you don't know whether the NPM module supports TypeScript, there's an easy way to find that. That's using that, finding that TS symbol next to any NPM module. It tells you that the NPM module has the TypeScript definition. We also wanted to use the mParticle NPM module, but it does not have the TypeScript support. But you see that DT symbol, that means that it's provided by Definitely Typed. So that Definitely Typed is a community repo where people provide the TypeScript support for NPM modules which are not available. So we used this one, and then it kind of worked out. So far, we saw that how we set up the Kotlin JS, whether we want the output as a library or an executable, or we also understood how we write the JS export and external declarations. Now, what about the actual multi-platform code? Now, multi-platform libraries, there are already a lot of support available for all the popular libraries like Kotlin coroutine, serialization, datetime. They're from the Kotlin itself. They all provide JS targets, so they already have the JS code. Ktor, which is a popular network client, it already has the JS available. SQLite, Apollo Kotlin for the database, they already have JS support available. The multi-platform settings library also has the JS and the Kermit and the UID library. So if you look at this, you feel like, okay, it's ready to go, and I can write a JavaScript library in a Kotlin multi-platform. But the problem is, for JS, the bundle size matters. Because the bigger your JS output is, it will impact a website performance. And then people might not be able to use your library because it impacts the load time or the performance impact. So I started doing some comparisons. I created libraries with MUN method, and then I added a Kotlin datetime library, and then in another project, I added just a serialization, so on and so forth. And then I ran some size numbers, and they are pretty dramatic because you see the Kotlin datetime adds 200 KB, serialization adds 300 KB. Ktor itself adds 862 KB. And then this was with the Kotlin 1.6.10. So if I combine them in one class with 50 lines of code, that was 1.3 megabyte. And that was after the dead code elimination. So that was such a huge JavaScript library. So if you tell a web developer, I have a library, use this, they will complain in terms of performance impacts. So Kotlin 6.20, 1.6.20 got introduced. I reran the same thing again. Not much difference except the Ktor that decreased that almost 200 KB, so the final size got decreased. And then lastly, Kotlin 1.7.10 introduced. I rewritten everything again. And that looks pretty promising at this point compared to the 1.6.10 because the Ktor almost decreased by 50%. And if you look at the combined code, it almost reduced by 40%. And this is just a 5 months difference. So it's definitely, with every new version, the Kotlin JS support is improving, and then the size impact is also reducing. Now, we could not use any of these libraries because our client project had important distinctions for the performance. So what we started writing alternatives. So for example, for date and time library, what we did is we created an expect class for instant, and we just pick and choose the APIs we were using from the datetime API. And then in the mobile main, we could just type alias the instant to the Kotlin X datetime instance. So at that point, so this is where the mobile main gets super useful because you want your Android and iOS to use Kotlin datetime, and you just write something in mobile main, so it helps on both Android and iOS side. And then on the JS side, we did the actual implementation using the js.date package. So then this way we could avoid using the datetime impact on the JS side, but still use it for the mobile and come up with a solution. Similarly, for the serialization, we did the same thing. We created an optional annotation called serializable. So this is the expect annotation, and also you see the optional expectation. So on the mobile main, again, we type alias it to Kotlin X serialization. So on mobile main, you still use the same one. And on the JavaScript side, you don't even have to write one because it's optional. So in common main, you can write something like all your data classes. So you don't have to have data classes separately for your JavaScript. So your common main, you're using that serializable annotation and then adding a data class. And using some more expect methods for the encode and decode, you can basically use serialization mostly on common main side. So that's all your common code. Similarly, for HTTP client, we did the same thing. We created an interface with most basic methods we needed, so like URL builders and the response classes. And on the JS side, we created the implementation using the fetch API. And then on the mobile side, we use the Ktor. So again, for the Android and iOS, the Ktor is still being used. So if you look at the final, like a full example, in the common main, we have the data classes, we have the API, which uses that interface HTTP client, and it basically calls that decode method. And so most of our code for all three platforms is right now in common main. The only problem here is that suspended keyword, because as I said, you cannot export suspended to JavaScript yet. So for that, on the JavaScript side, you have to write a lot of like a facade layer or like a wrapper functions for most of your APIs. So here, I wrote a wrapper for my getAstro method, but I'm now returning a promise instead of the suspended function. And then Kotlin coroutines library has a handy function to convert the functions to promise using the global scope.promise method. So things to keep in mind. You have to rethink about your architecture when you're adding the JS, especially what you want to use, what third-party libraries you want to use, how much performance impact you can have using the third-party libraries. So as I said, keep checking the JS library size because that will impact your performance. You don't want people to not use the library. Also, you will have to write the facade layers because since not everything is exported, you want to make sure that you are exporting the correct JS APIs. And be prepared for surprises because it's not ready, but it's definitely good to go in terms of we use it in 2 production projects and it's working out fine. So what's the buzz around Kotlin JS so far? Well, we just saw 2 presentations talking about Zipline from Jake and JC, and they are using Kotlin JS for the Zipline, so it's definitely used there. JetBrains has a product called Space, which is the collaboration tool. JetBrains built the Space using Kotlin JS, so the front end is completely built using Kotlin JS, and the back end is and the shared code is the Kotlin Multiplatform with Android and iOS apps. And if you look at the Kotlin Slack, I just sorted the channels by number of members. JavaScript is pretty high on that. It's like 35,000 people. So definitely people are checking out JavaScript Kotlin support and are interested in it. So yeah, let's see how the buzz keeps going. And that's about it. Thank you for joining. And that's the view of Toronto, where I am from, Canada. And then you can reach out to me on Slack and Kotlin and Twitter.